Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, how are you today? Today we will learn about mathematics, yes, of course. But today our lesson is application of the second derivative. But before that, if you like my video, please like and subscribe. And then if you have any suggestion for my video, please give me a comment in the link below. And then I will check it, and then after that, so please enjoy the rest of. Okay everyone, application of the second derivative is divided by two. The first is concavity and the second is the second derivative test. So now we will talk about concavity. Okay everyone, as we see here, concavity, let's see as a make to graph. The left graph is increasing, but this one is concave up. As we see, they are up to the right side. In here, increasing, but concave is down. Okay, you already know. Concave up and then concave down. Concave up, you can see from A to the B, they are up. And then concave down, from A to the B is down. Okay, in concave up, they told us about concave up if F lies above R, the tangent line. Okay, how about concave down? Concave down is the same meaning, but if F lies below all of tangent. Okay everyone, so you know how to make the difference concave up and concave down. Okay everyone, from here we are see to graph in the left side and then graph in the right side. Graph in the left side, we already know this one is concave up, that's the meaning they have slope increasing. And then in the right side, they told us about concave down and then slope decreasing. Maybe you will be curious, why miss this one is slope increasing? From the beginning, we already thought, we see the graph is from the left to the right. From the left to the right, correct. From here, we can identify why they told us this one is slope increasing, why this one is decreasing. Increasing, we can see from here and here. This one is A, B. This one is in interval. Interval from coordinate X and Y. And then from here we are C. This one is increasing. Okay, you already understand about slope increasing. How about the right side? In the right side, you take A and B, and then this one is A, this one is B. From here they are down. Because it's down, is that the meaning why? Slope decreasing. Understand everyone? Okay, so the theorem, they thought that about slope increasing, about concave up, if, number one, if the second derivative more than 0, is that the meaning concave up. Okay, because number second is if the second derivative less than 0, is that the meaning concave down. But you must remember, this one is on interval. Okay everyone, on interval E. Okay, I think you understand what I'm explaining. I will give you example right now. As determine where concave up and concave down. Okay everyone, determine where the concave up and concave down. From here, if the first A fx is equal 9 minus x squared. So you need to find the first derivative about this one. First derivative about this one is minus 2x. Okay, and then the second derivative of x is minus 2. Since the second derivative is less than 0, so this one is concave down. Okay, because this one is talk about concave down, so the picture will be like this one. So this one is y equal 9 minus x squared. Okay, and then the second is fx is equal exponent power x. So we already know the first derivative of exponent power x is their self. And then the second derivative of exponent is their self. Okay. when we derivative about this one, the score is more than 0. Because what? From here, we already know the coordinate is 1 minus infinite until infinite. And then, when we make graph about this one, they are up. Okay? So, this one is graph exponent power x. Okay, everyone? Okay, everyone. How about another example? Another example is C fx equal x power 3. So determine where concave up and concave down. From here, we need to derivative. The first derivative is 3x squared. Okay? And then, the second derivative is 6x. So, from here, we setting the second derivative x equals 0. Okay, so 6x equals 0, so x equals 0. So you need to make sign chart after this. The sign chart, okay, I think this one is not enough. Okay, on the right side. From here, okay, because x equals 0, so this one for x, this one is 0, this one is minus infinite, I mean this one is plus infinite. So this one is for the second derivative x, this one for fx. Okay, we need to take another number from 0. So we want to take 1. 6 times 1 is positive. And then, when we want to take minus, okay, minus and plus. So this one is concave down, this one is concave up. Okay, so everyone, as you see from here, there are from here from the sign chart we are see in the left side of the 0 is minus, is the meaning concave down. In the right side of 0 is plus, is concave up. Okay. From here, the point 0 until 0 on the graph fx equal x power 3, where concave down to concave up, we call it inflection point. Okay, everyone? So, I will explain about what is inflection point after this. Okay, everyone, what is inflection point? Inflection point is a point where a graph changes its direction of concavity. So, this one is here or not each inflection point, either the second derivative is equal 0 or the second derivative doesn't exist. Okay, everyone, how to finding the inflection point? Finding the inflection point is divided by two. The first, you need to find the points where the second derivative is equal 0. And then you must make sure that the second derivative of x doesn't exist if doesn't have equal 0. So you must to make it equal 0. And then number 2, construct the sign chart of the second derivative of x if the sign of the second derivative of x change across the point x equal a, then a, fa is the inflection point. Do you understand, everyone? Okay, everyone, now example 36. Example, they told us investigate fx equal x plus 1 power 4 for concavity and inflection point. Okay, now inflection point, let's say IP, is to make it easier. Okay, from here you need to make it the second derivative. So the first derivative is 4x plus 1 power 3, and then the second derivative is 12x plus 1, 2. Okay, because you should make this one to be equal 0, so you have the same root or double root x equal minus 1. Okay, everyone, because you already get x equal minus 1 from here, and then you make sign chart. Okay, this one is x, this is the second derivative of x, this one is fx. Because x equal minus 1, so let's put this one is minus 1, this one is minus infinite, positive infinite. let's take 0 from here. 0, positive. And then, sorry, I mean in here, and 0 from in the right side is positive, and minus 2 from here, because this is square, this one is positive. So this one, the both of them is con up, and then this one is con up. We get x minus 1, comma, this one is, when you put this one to be here, is 0, minus 1 is 0, not inflection point. Because of why? Because the second derivative doesn't change side across. Okay, example 37. Example 37, they told us find the interval concavity and inflection point for fx equal half x power 4 minus 4x power 3 plus 9x square minus 7x plus 5. So you need to make the second derivative. Okay, the first derivative from here is 2x power 3 minus 12x power 2 plus 18x minus 7. So you make the second derivative about this one. The second derivative about this one is 6x power 2 minus 24x plus 18. So, because we don't know about this one, you need to make the setting equal 0. Okay, everyone? And then, after this, you make a factorization from here. Minus 3x minus 1. Okay, so we will get x equal 3 or x 1. And then we make sign chart. Okay, we need to make sign chart. X, the second derivative x, fx. This one here have 1 and 3. This one is 1 minus infinite. And then this one is 3 positive infinite. Let's take 0 from the second. 0, 0 plus. And then 2. 2 power 2, 4. 24 minus is minus positive. So this one is concave up, and then concave down, and then concave up. Okay, you already know concave up and concave down and concave this one. So they taught us interval. So interval from concave up is minus infinite until 1, and then 3 until positive infinite. How about concave down? Interval from concave down is 1 until 3. Okay, everyone? So we need to find the inflection point. Okay, everyone, from this question we get the sign chart, the chart sign, and then they have changing. What they changing? From the sign up to be down. So this one is IP or inflection point, and from here they have different sign, atau they change sign. So this one is still inflection point. So the inflection point is 1 to be F1 and what? And from here, and 3 from F3. So that's the way how to find the inflection point of 1, F1. So you can substitute this one to be the function. The function is fx equal half x power 4 minus 4x power 3 plus 9x squared minus 7x plus 5. So you can substitute x to be 1 here, and then half minus 4 plus 9 minus 7 plus 5. Minus 4 minus 11 minus 2 5 3. Okay, 3 7 per 2 or 7 over 2 I mean, or this one is to be 1 over 7 over 2, or you can substitute this one to be like this one too. Okay, everyone, so we will next to the another question. Find the interval, concavity, and inflection point from fx equal constant x minus sinus x on 0 to v. So you need to make this one to be have second derivative. So the first derivative is derivative of cos is minus sinus x. Derivative sinus is so minus cos x. Okay, so you need to make the second derivative of x is derivative of sinus is cos. So minus cos. Derivative of cos is minus sinus. So to be it's to be plus sinus x. So this one it will be setting to be equal 0, and then this one you make this one is divided by cos x, cos sin x. So this one is to be minus 1 plus tangent x equal 0. Tangent x equal 1. What's the tangent? Have the score 1. What's the degree? So the degree is p over 4 and 5p over 4. Okay. So from here you make same chart. So here x the second derivative and then the fx. Okay, this one is 0, v over 4, and then 5p over 4, and then this one is 2v because they have interval. Okay, so from here we get minus, plus, and minus. You just need to substitute this another score to the second derivative and you will get the minus, plus, minus. And then this one is concave down, concave up, and concave down. So the interval concavity is from interval concavity down is 0 until p over 4 and 5p over 4 to v. Okay, everyone? And then interval concavity up from v over 4 and then 5v over 4. Okay, now we need to find the inflection point. Okay, this have changed the chart sign. So this one p over 4 and then f p over 4 and 5p over 4 and then f5p over 4. Okay, so you need to make sure this one, what's the curve of the function p over 4 from this formula. Cos p over 4 is half square root of 2 and then sinus of p over 4 is half square root over 2. So this one is to be v over 4 is 0 and 5v over 4 is correct. It's 0, 2. So everyone, it's easy, right, to find the inflection point. So let's try another example. X is equal x power 3 plus ex power 2 plus bx plus 3 has inflection point is 1, 3. Find the value of a and b. 1 and 3 is f1 have score of 3. So you need to make sure this one. The first derivative of this one is you will get 3x squared plus 2ax plus b. The second derivative of x is 6x plus 2a and then equal 0. Okay, everyone, you get this one is equal 0. Since 1, 3 is inflection point, so that's the meaning the second derivative of 1 is equal 0. Okay, and then you need to substitute to be this one. 6 times 1 plus 2a equal 0. 2a equal minus 6. A equal minus 3. Okay, everyone? We get the a equal minus 3. And then, we need to find another. We need to find b after this. From here, we get what? We get f1 is equal 3. So, you need to substitute this one to be from here. So, f1 is equal 1 power 3 plus a times 1 square plus b plus 3 equal 3. Okay? 3 we can cancel each other. Okay? And a change to be minus 3. 1 plus minus 3 plus b equal 0. Okay? Minus 2 plus b equal 0. So, b equal 2. Okay? I think you understand what I'm explaining today. I hope you more learn about this way, how to find the inflection point and then the concavity. Thank you for today. I hope you enjoy my video. And then I hope you understand what I'm explaining today. And then please enjoy my video. If you like my video, please thumbs up, like, share, and comment. And then I hope you more learn about the application of the second derivative about concavity. Next meeting, we will talk about the second derivative test. So please enjoy. Thank you for today. Assalamualaikum warahmatullahi wabarakatuh. Bye.